course, and so there's a whole bunch of different spanning tree protocols available, and you got to know the switch, what it supports, and so on. But the bottom line is, whenever you have something like this, logically the spanning tree protocol is going to cut one of these lines and break that loop, okay? And it's done logically, which means physically still traffic can go through, but logically it will not let traffic go around. And I mean, the physical wire is still there, right? But you know, logically it will put some of the ports in a blocking mode where it does not let traffic to go through, and basically blocking and eliminating the loop. So we have that, and then we have the inter-VLAN routing, which is, I think, well, it is important, but it is a very simple topic. And that's the, once we have VLANs, then we have to know how to make people go between VLANs. And to have traffic goes between the VLANs, then we need to implement the inter-VLAN. To do inter-VLAN, then we have to implement frame tagging, like 802.1q, and that is basically using the routers to do that. So routers come back in action in the switching, because you are not able to, you know, when you have a switch and you said, okay, these 3 ports belong to VLAN, let's say VLAN 10, which is, let's say, sales. And then another, let's say, 3 ports belong to VLAN 20, which is, let's say, human resources, HR. So what we're doing in here is that we are separating the traffic. So the traffic between these 3 ports is not going to be visible to what? To those guys, correct? And the traffic in here is confined here. So any broadcast, any multicast, anything that happens in here, okay, this, I don't know, this network blows up, whatever happens, this is not, nothing is going to be seen on these, even though they're connected to what? The same switch, okay? But then once in a while, you know, you might have a server in here that needs to be accessed by some of the user here. So you need to jump from this VLAN and get into that virtual network. To do that, you cannot do it by using a switch. A switch does not have the capability to do this communication between the VLANs. So then what we're going to do is we have to take one port and connect it to a router and have the router do you send the data to the router, and the router, if it sees it, okay. If it says it's fine, if you have access lists to say yes or no, then it will either forward the traffic or block the traffic. So routers are back doing this job, okay? 2 methods we're going to do it. We're going to do it router on a stick like this, which is basically an external router, alright, connected to a switch. And of course, the preferred method, which is using a layer 3 switch, which means basically the router is built into the switch, like the 3550, this is 2950, this is 2600, whatever kind of routers you have, it doesn't matter. So, so we're going to do this, we're going to learn that, we're going to learn how to program the switch and make VLANs. We're going to learn how to do the spanning tree protocol. So these are 3 big topics: VLANs, inter-VLAN. This is called inter-VLAN routing. So there's inter-VLAN routing, there's VLANs, there's a spanning tree to control to break logical loops. There is VTP, virtual trunk protocol. The VTP is basically another protocol that we're going to use at the beginning, and it's to communicate between the different VLANs and synchronize. You will see how that goes. You need to know the operations of that, and there's a lot of questions in the CCNA test about BTP operations, you know, especially in the troubleshooting part of that. You gotta know how to troubleshoot when VLANs are not communicating with each other. Now, there is two new topics that are not included in this, but they are included in the CCNA test, and they are in the they're in addition to the curriculum, and one of them is called the ether channels. Ether channel used to be a CCNP topic.